Now that you know how to use the molarity formula and get moles, we can use this in stoichiometry. Yay, your favorite subject. Actually, some of you people do love stoichiometry. So, stoichiometry in solutions. Let's remember that our key to stoichiometry is getting that mole-to-mole ratio between two different compounds in a reaction. And we can get moles using molarity times liters. That's going to equal moles. Okay, so my first example is hydrochloric acid mixes with magnesium hydroxide and it forms magnesium chloride in water. So if I have 500 milliliters of a 1 molar solution of hydrochloric acid, how many grams of water can we make? So what they gave me was 500 milliliters a 1.0 molar solution, and they want us to find grams. So again, it's stoichiometry when you're doing this between two different compounds. So now we have a new thing to add to our map. We had gas volume not at STP, and we used perv-nert to get to moles. Okay, and now we have liquid volume. So we already talked about our liquid volume is going to be molarity equals moles over liters. So to get back and forth, we are going to rearrange that formula to get to moles. If I have moles, we can find our volume. Okay, so both sides, we're going to put it here. Molarity equals moles divided by liters. Okay, and make sure you remember this is liters. I know in dilution it doesn't matter what it was. That's because we have volume on both sides and our units will cancel out. But when we're using just the molarity equation, you have to change it to liters. Okay, so back to our example. So I have this, and I can calculate moles, and I'm going to grams. So what is our path? Well, I'm starting with a volume of liquid. Okay, I'm going to use my molarity formula to convert it to moles, and this is HCl is our substance A. Then I'm going to use my mole ratio of hydrochloric acid, HCl, to water to go from moles of substance A to moles of substance B. And finally, they don't want it in moles, they want it in grams, so I'm going to convert it to grams. Okay, so you can actually do a whole string straight through, and I'll show you how, but some people like this broken up. So the first part is I have my volume of HCl and I need to turn it to moles. In order to do that, I have to have that molarity, which it gave me. Molarity times liters equals moles, and here we go. And I get 0.5 moles of HCl. So now I'm going to start with 0.5 moles of HCl. Right here is my moles of HCl, and I need to go whoop whoop to moles of H2O, and then I'm going to convert whoop whoop moles of H2O to grams. So I don't want moles of HCl, I put it on the bottom, and I do want moles of H2O. Okay, that's great, my moles are gone, and now I'm on moles of H2O island. I don't want to stay there. How do I get off? I put moles of H2O on the bottom, and I'm going to grams of H2O. So now I have moles to moles. Let's just do a reminder again, moles to moles. When I have mole ratios, I use that coefficient from the balanced equation. H2O is up here. Okay, that's a 2 in front of my H2O, and HCl is here. That's a 2 in front of my HCl. Okay, and for every 1 mole, I have 18.02 grams of water, 2 H's and 1 O added together. So multiply by the top, it equals, divide by the bottom, multiply by the top, it equals, divide by the bottom, and my answer is going to be, so you should have gotten 9.01 grams of water, and I only was given one significant figure, so if I'm doing sig figs, it's 9 grams of H2O. Now I alluded to the fact that this could be done all in one step, so we would start with 5 liters of HCl, and remember our molarity is moles over liters, so 1 mole per liter of HCl, and I have it flipped correctly so my liters cancel out, and then I'm at moles of HCl. I off moles of HCl island, I go to moles of H2O, get rid of moles of H2O, go to grams. So you can do this in one string. A lot of people like running those whole strings, but some people want it broken down to understand it better. Okay, now just because we started here doesn't mean we have to. We can go to gram, we could be given grams, and they want to find the liters that you need to start with, but they'd have to give you the molarity of the solution, right? So I can go backwards. I can start at grams, and they want to know how many liters of a certain solution to use. Now, we've done stoichiometry enough that I'm not going to do an example, but when you have that problem, if you need me, I will help you through it.